the point of, I'm not sure exactly what we're trying to do, but I think it was mostly to see, for two things I think we're going to try. The first is, for those of you who haven't been able to really get started at all, I'm going to try to work some very simple examples. And those are going to be the first two examples that we do. And we're going to try to understand everything that goes on in those examples. So if there's anything that you don't understand, just ask a question and we'll stop and explain it. And then if you can't get it, or if it takes too long to explain, we should just delay, but I'll talk to you afterwards, okay? Because we need to, it's far past time for you to get started, obviously. So you need to understand everything, and you don't want to be writing anything you don't understand at this point. Okay, so, when you're doing a test, obviously. When you're experimenting, you can do that. But, all right, so our first example is we're just going to find the minimum of, we're going to write a function, and the prototype looks like this. And we'll first write the function, then we'll write the tester. Now, I'm going to make a lot of mistakes. Don't anyone call out and correct me until I'm done, because I need some time to correct them, just like you might. And then you'll get to see the error rate that I have on assembly, which is always high. Just as I may have mentioned in class, I would not make 100 on my own exam. Nobody writes perfect assembly. Okay, so this is what we're trying to do, find the minimum use value, and this is an example because I thought this is going to give you the easiest access to an ABI. We've got two parameters coming in, we've got a return value, we've got to use an if, but it's an extremely simple routine, right? We're not doing any kind of arrays yet. We'll do one of those later. And in the third or fourth example is going to be something like that, a little more complicated. And that, I think some of you were wanting to see basically how I problem solve when I write deals, and that will give us more scope for that. Okay, and for the Spectre one, I have a tester already written. For this one, we'll write a tester. All right, so the first thing I'm going to start out with, just like in Java, there's some boilerplate code that you always churn out. The same thing happens in assembly. And the boilerplate code, in this case, I'm going to start with, I always begin with this. Let me put a few comments just to help. What this is, tell the assembler following lines are code. That's a command to the assembler itself. Because the other thing that you might be doing in an assembly thing is you might put, you remember we talked about there's global data, which is stored in the data section? Well, if you do .data, you can actually give a series of bytes that get stored into global data. That's how you create a global data before your program runs. You put it like this. Now, we're not going to cover that in the exam, but I just want to let you know that's why you have to specify. Because remember, the assembler, unlike the compiler, is a very stupid piece of software. So it doesn't know what you're doing until you tell it. So we're going to tell it, we're providing you with code, or assembly. Okay, so, and now, we're writing a function which has to be called, and the call is really another word for, it's going to be jumped to from an unknown location, right? So, in order to have any jump work, and a call is just a specific version of jump, you need a label. So, in this case, on Linux, on 32-bit Linux, the label is just the name of the function, and that's what the call will do. So we're going to say get min. Now we don't have everything we need yet, but I want to start with this. Now, by default, labels different. There's two scopes for a label. One is a local scope, which means you can only jump to it from something inside of the file. The other type of a label is a global label, which can be jumped to from anywhere. Now, most of the time, for correctness, you don't care which labels there are. As long as you're jumping only within the file, which is a local one, if it's a global, it doesn't hurt you, right? However, if you try to make a function call that is local, people outside of that function cannot jump to it, right? And therefore, for correctness, it's important that we actually tell the assembler that this label is needing to be a global label. And on Linux, we do that by saying .global, and then we have to give the name of the label that's .global. Okay, so this is essentially the boilerplate code that's going to look at at the beginning of all your assembly routines. And just to point out, some of you didn't always put the function label at the top of the function. Now this will actually, if I put an instruction above that label, right, I put an instruction like here, as an example, that instruction will never be executed, right? Because the jumps to get min, and all the instructions above it, there's no way to get to them, right? So we have to have it at the beginning. So, okay, so let's go back to this guy. Any questions so far on the beginning stuff? Okay. Okay, so, and by the way, we're writing this in O1 for the first example, getmin .S, which tells GCC that it's an assembly file with CPP commands, right? And that's why we're allowed to use C comments, is because CPP will take care of those for us. Okay, so now in getmin, we're going to have to, so oftentimes before I think about the function now, I've got the boilerplate code at the beginning. I need some boilerplate code at the end as well, which in my case is going to be return, right? And I'll have other stuff in there maybe later, but I'm going to start with that. And I'm going to remind myself at this point, EAX better have min. So let me now mark this guy out. The return value of the function is going to be an EAX. This is going to be at 4 ESP. And this is going to, and now I got 4 because the return address is 4 bytes, right? And the return address is at the bottom of the stack when according to the ABI. And so that's the memory. It's good to have a picture, get as close to the screen as possible. It's good to have can you see over there? It's good to have a picture of the stack. So the stack presently looks like return address at the bottom, that's 0 ESP, right? And then what we know from the ABI is that the parameters just go after that basically in their order. So I1, and to know what the index, so that guy started at 4 because the return address is 4 bytes, right? Integer are also 4 bytes. So I2 is going to be here at 8, right? And now we don't actually know what's above this. It's memory that's owned by the calling function. So it's not, we shouldn't read it. And if we tried to write it, then we're causing errors, right? Okay, so that's the picture of the stack, and that's what I'm showing here. Any questions so far? Okay. So now I'm going to go ahead and start loading my parameters. So I need to get I1 and I2, and in assembly it's nice to have them in registers. So now I'm going to start using CPP to make things a little prettier. And by the way, what we can do, and what I recommend you do, I'm going to get rid of this comment, it's kind of noisy. And let's write the function more like what we're going to try to write it as. And this is, it's not so much necessary for a simple example like this, but on the exam sometimes if I ask you something with multiple things to think about, it can actually be hard if you're not super good at assembly to immediately write it in assembly. So it can be easier if you first express it in a high-level language that you're comfortable with, and then translate it, right? So that's what I'm going to do here. We don't have a max instruction that we've learned in this class yet, so I'm going to write it with branchless, which is going to look like an if. So something like this: if I1 greater than or equal to I2, return I2, return I1. That's a valid implementation, right? We'll see, I may not choose to use that one, but that just gives me something to think about. Okay, so now I'm going to do my CPP commands so I can have registers have some good names. So now we'll say, I'm going to make a comment to myself, I1 is the return register. All right? And say integer return register. And so what this means is I'm going to want to put min in, right? And now the good news for me is that in this function, it's 50% likely it's already there, right? If we know nothing else. And so we might as well have one of the guys be the min, unlike what we do maybe if we had a vector to look through, or an array. Okay, so that's going to be EAX. Now, I've got here, brought myself some notes. Hopefully I won't have to access these. These are the slides of the actual lecture. This is the reference you all had on the exam. And I'm choosing these registers, of course, since I'm not making any function calls, I might as well use the caller saved registers, the ones that has the callee. So if I was calling another function, the caller saved registers, I would have to save and restore them before, if I cared about them during the function call. But because I'm not calling anybody, using them is essentially free for me, right? So I'm always going to use, when I'm not calling somebody, at least, the caller saved registers, which are EAX, EDX, and ECX. Those are always going to be my first three choices of registers. Okay, so I'll leave a comment there. Thing to note about CPP, the definition is pound define the alias to the thing you want to substitute for it, right? It's going to look every place there's an I1 and it's going to replace it with EAX, right? No commas or anything. If you put a comma in there, it becomes part of the definition or the handle, right? So, okay. So now I'm ready to do something. And so far anyway, I don't need to use any registers that I have to save, right? So I'm not going to even allocate any frame yet. I'll go back and add it if I need it. Now I'm going to load from memory. So I'm going to have to use the correct move, and assembly doesn't care about case, so just to make this a little clearer, I'll try to put the suffix that tells you how long it is in memory. Every time you access memory, no matter what the data type is, you have to tell it how long a piece of memory to read, right? And L for integer operands means 4 bytes, right? And now, how does it know this is an integer operand? Well, move is an integer instruction. L means it's 32-bit, but we'll also let it know in a second on what register we use. Okay. So now, I'm going to move that guy. So I want to get, let's see, do I have? Okay, so the address I want to load from is 4ESP to get I1, right? So I'm going to get I1 here. And now notice, anytime you put a parens, you're going to have an addressing mode, which means you're going to access memory. There's one exception to that. What is that? When you use an addressing mode and yet you don't access memory at all. There's only one place in assembly where when you put it in addressing mode, which you can tell is happening usually by the parents, that it does not mean you're accessing memory. In all other instructions, if you're always accessing memory, you use the addressing mode. Leah, right? Leah allows you to use something like an addressing mode, but it doesn't do anything to memory. It doesn't read memory, it doesn't write memory, right? The computation doesn't have to be an address, even though it's called load effective address. It just does the computation using the same syntax, okay? So, other than Leah, whenever you see something that looks like that, that means you are either reading or writing memory, or you're doing both. You're reading and writing memory, okay? So you're accessing memory in some way, except when you do Leah. Okay? So now I'm going to move that now to my I1 register. Right? And now, I got that obviously just by looking at my picture that I drew here, or by looking at this picture here. Right? Any questions on this so far? Okay, so I've got the two values in, and I already have the answer, right? Like I say, if we know nothing else, we would guess 50% probability I've already got the right answer. So now, when I look at doing a comparison in a branch, the funky thing about it that you have to remember is you do the comparison, then you have to chain the branch with it, because the comparison actually writes to the condition codes, right? So when I do that, you want to use a comment, because you have to remember what order it cares about, right? And when we know about branches is that they always care, it's always asking, you're comparing against the destination, okay? And so a comment can help you do that. So let's now do that. Compare I2 to I1. Now I'm going to write over here what I want it to be. I want something that says, if I1 already has the minimum, then all I have to do is return, right? Because I've already got I1 and EX, which is the return value. So I want to check the other case when I1 does not have the min. And in that case, I'm going to jump to some code that's going to set the min, okay, to the correct thing. So what I want to say here is that the case where I need to change it is when I1 is bigger than I2. If I1 greater than I2, go to I2 is X. Okay. All right, so now I've got to figure out how to do that. And now, notice that I'm doing my comparison with two registers, and therefore I do not have to add a linked suffix. Yeah?
Why would you try to check for the keys where you have to change? Why would you check to see if I1 is smaller, and then you can just end it, and if not, then you keep going?
Well, because you don't really have an if, right? You have a jump. And so what I'm going to do is in the case where it already isn't, I won't take any jump at all. I'll just fall through and return. But for the case where there is a jump, I'm going to go down. So now I could reverse that, right? I could take the jump in this case and not the other case. And some of you always jump one way or another, but you don't have to. And usually if you have only two choices, then there's only a need for one branch, because the other choice is the first branch was not taken, right? And let me write that, and I think it'll be clear. So what I've written here is because assembly has no real if and go to, but that's the closest thing a high-level language might have. I mean, we could write this as like a Java if branch, but that's not going to help us translate it. So it's easier to go to this pseudo level, and now we're going to be able to translate what we want. So what I'm saying is, and let me just see. Let's pretend now I1 has the right answer. Then I can just fall through and return and I'm done. Right? This function is complete in that case. And so I don't actually have to do anything when I1 is already the minimum. Right? So the way I'm thinking is, when I1 is not the minimum, go to a new section of code and I'll set it to the minimum. Okay? All right, so I've compared the two, so now I've got to choose my label correctly. So I'm going to use jump something, right? Now, what I want is so I1 is the destination, right? Which it's always source destination. And so the comparison on the jump part is always in terms of the destination. And that's why I wrote my if with whichever of these guys that I chose to be the destination. I put it first so I can think about it, right? So I want I1 greater than I2. So my branch is going to be JG, right? Now if I did unsigned, I believe it would be JA, right? But jump if above, right? But there's no reason to think of this as unsigned, though it would be. Either one will work as long as it is unsigned, okay? All right, so I'm going to say jump greater. Now I've got to build this guy, I2 and now, by the way, I'm actually done there. And I can put a comment here. Okay, so now in this case, all I've got to do is put since I've already checked that I1 was not the minimum, that means obviously I2 is the minimum, right? So all I've got to do now okay, so this should be my completed code. So I give something to jump to. I load things from the frame size. Now normally, of course, we'd have to deallocate space off the frame, but here I didn't use any of that stuff, so I didn't allocate any space off the frame, right? So that's why we don't see the subtraction at the beginning of the ESP pointer and the addition at the bottom. And now it would be a good idea, but not required for an exam, but that tells, no matter what the default is, this will make sure that someone can't jump to the middle of my function, right, from outside the file. But that doesn't affect correctness at all. And the other thing you might think about doing is instead of saying I1, since you really want to set EAX, you could do that explicitly here, right? That's obviously the same thing since I1 is EAX, right? But all those guys make sense. So now, any questions or does anyone see errors?
You didn't set where to jump to. You just said jump.
Oh, you are correct. That is a error. My comment does not make it happen unless I get it to. Okay. Maybe I'm going to look at here before I ask for more errors. Okay, so now, yeah, so let's think about this. What do I look for when I'm thinking about errors? The first thing I would look for is, do I have the beginning? It's really easy to forget that. Okay, have I put the label up there? Do I have .text? .text is one I easily forget. And then I'm going to look down, and normally if I'm actually saving and restoring registers, I'll check at this point that my restore matches my save. You know, I'm not scrambling, I'm putting EAX in 4, and then loading ECX from that location to memory, right? I check that. So that looks good. The thing that I mess up the most is failure to put the length on every memory operand. So I'm looking through here and I only see 2 memory operands here, and I've got the length there, and these are integers, so that is the correct one. So that looks good to me. Okay, I think that's good. Anybody else see? Yep.
Why do you have max? You say I2 is max.
Because I'm an idiot. It should be I can admit.
I mean, it doesn't matter. It's not gonna.
I mean, the assembler, of course, doesn't know the difference between max and min, right? But yes, you're right. To someone grading, that's confusing as heck, right? Because I've just said it is the opposite of what it is.
Don't forget to change one line below.
So let's see. Okay, we got all these things have to match now. Yep.
Okay, so the way I solved it a little bit differently was instead of, so I did the comparison the exact same, but my jump was less than to a done that just has like, well, I mean, I wrote it down, so you want to see it.
Okay, yeah, we can write this to another way in a second. But let's finish. Question back there?
I was going to ask why the move to the bottom doesn't have a link specified. The move by 2 to presenting AI.
Here,
Yeah.
because these are both register operands,
Oh, okay.
and anytime the operands are both registers, it just looks and says the person is using, I2 is going to be replaced by ECX, and it says ECX and EAX are both 32-bit registers, so that's a 32-bit move.
Okay. Whereas the other two above have memory accesses, so you
That's
can
right.
specify it. Okay.
And with every memory access, you have to tell it how much to load. And L is for integers, B is for a byte, which is if you do a car. So now, before we go to alternate implementations, let's make sure this actually works. Oh, and we might also want to write a tester for this guy. Now, for a tester, let's. So let's call it G01 test.c. Okay, so first, before we do anything else, and we're going to have to remember that all our compile commands, we need the dash M32 to tell it we want 32-bit ABI. So now we're going to find out, okay, we got something that compiles a bit. So now let's write a tester.